what is the difference between genetics and functional genomics?
So genetics is the foundation for functional genomics, right? That's an important question because it's only through functional interpretation that we were able to apply this science to things like environmental health. So genetics is, let's study a bunch of genes and let's figure out what each gene means and give that gene a problem that it's attached to. For example, there may be a breast cancer gene, there may be an Alzheimer's gene, and it gives you some layer of propensity or risk. You got an 80% chance of this, a 30% chance of that. In that, it ends at the discussion of the gene.
Right.
Functional genomics is, first of all, the body isn't a bunch of independent genes. There's systems and pathways we already understand. And detox is one of the huge areas we're going to touch on and why systems are so important. If you first map those out, we already know how the human body works. So we don't need to reinvent that by now saying, let's look at things genetically. No, let's have the genes mirror the way the body works. There's a hormone system, there's a neurochemicals of the brain, there's certain detox pathways and elimination pathways. We already know what's going on. We need to then interpret DNA in that context to drive certainty, not this probability, maybe you might get breast cancer, right? From there, we then still know that if you take 5 people with the same profile, whether it's their hormone profile, their brain profile, their cardiovascular profile, not all of them manifest the problem.
Right.
Why? Because the epigenetics of my environment, nutrition, and lifestyle are the load that pushes me over the edge. So if I say that your cardiovascular hardware is not the best, it looks like you have risk for inflammation, it looks like you have risk for potential cholesterolemia and cardiovascular disease. All I'm saying is it looks like that. You have bad hardware. But if you put that bad hardware on a beach with sunshine and fish and out of the sea and no stress and reading books every day, you're not getting sick.
Sold. Where is that place? Where am I? I want to go there.
Yeah.
No, I want to pause for 1 second.
Sure.
Because we talk in the summit, we do talk a lot about epigenetics, and people sometimes come in from different places. So let's talk about, what does epigenetics mean?
Sure.
Because it's a relatively new concept.
So there's two ways to look at it. So epi literally means above. So here's your genome, right? And here's the things happening above your genome, the inputs of environment, nutrition, and lifestyle, which can turn the dial on your genes. So if you have a gene that does it, what is a gene, first of all? It's an instruction telling your cells what to do. Different types of cells know what page of the book to read. So a heart cell becomes a heart cell because it only reads the heart cell instructions of the DNA, right? So all these cells are doing different jobs. In that, if you have a good version of a gene that, for example, moves cholesterol around, lipid transport, there may be certain foods, certain chemicals, certain stressors that cause that gene to speed up or slow down. That's epigenetics, right? So the expression of the gene, how hard is that gene actually working? You have a Ferrari, are you pushing the gas pedal to the floor or are you just tapping it, right? That's kind of epigenetics. You know what you have foundationally, but how hard are you pushing it based on the other inputs? That's one way. The other way to look at it is, I have risk or propensity, but I don't have an innate problem, a prescriptive problem, until I've made the wrong choices. You talked about, before this, we were talking about some chemicals and your trip to France and mind-blowing story about lead in the air, right? So you could have 5 different people for 5 different outcomes. First of all, risk propensity. How well do I do that job? Now, what load did I put on that job? If I don't do a good job of filtering chemicals that I'm breathing in, my glutathione pathway, there's certain genes that instruct that, and I am breathing in chemicals, well, I'm going to get sick a lot faster than the person that does a good job of filtering, right? So we can start to layer on, and then the last item I would say that is typically not spoken of in epigenetics, but is super important, especially when it comes to the brain, is context. So there's your genome, here's what you do well and what you don't do well. Here's epigenetics, here's the triggers that push you one way or the other. And then there's context, meaning that I have a risk or propensity towards addiction. But if you put me in a place where my parents passed away at age of struggle and make my money, I'm going to become entrepreneurial. Because that same pleasure or reward seeking path, I'm putting in a different context of needing money, right?
Interesting.
If you put me in Richie Rich's house in a mansion, then I might get depressed because nothing gives me pleasure anymore, right? If you put me in school with my friends with some cigarettes that are being passed around, I might become addicted. So the context really drives, again, take the Ferrari example, put it on a nice paved road, put it off road, put it down a hill, up a hill, it's going to do different things, right? So that's kind of look at it.
So the thing that's actually a really great example. The one thing that I will kind of add is genes are not your destiny. Is another. So it's a propensity, like you were saying, but it's not. You have to have certain context, i.e., toxicants or sugar or inflammatory marker or whatever it is, and then they get activated, etc.
Yep.
The cool thing about epigenetics that I always think about is when I talk about epigenetics, which is a little off topic, but I'll say it anyways, which is so genes are fixed. They come from one side from your mother, one side from your father. They're fixed. Epigenetics is actually a living system, and actually what happened to your father and what happened to your mother and what happened to your ancestors actually does change your epigenetics. And what happens to you in your life changes what happens to your kids and grandkids, etc. So it's a cool modifiable thing.
Yep.
Even though genes are stuck, your epigenetics is not. And it's up to you to do it. Yeah, please.
There's lots of examples. So there's first of all, if you look at this sort of chronologically, there's two different ways to look at this. And this is where people get lost in the very first thing you said, which is that, we kind of aren't designed for our environment. There's all these things that we're breathing in and eating, right? So I'm going to talk about that in a second. But first, the way we usually think when we think ancestrally is we think about mom and we think about grandpa and maybe great grandma, right? Maybe we might go that far. So we're thinking that that's my ancestry, that's what I inherited. And so it's absolutely true. You take something as significant as the Holocaust, for example, that happened in Germany, there's proven epigenetic methylation markers that are expressing in the next generation where they're experiencing trauma from what their parents experienced. Because something that intense in nature affects the genome to the degree where it thinks it's meant to protect. Let's pass on this protective measure to the next generation. They have the same genes, but we're going to activate some stuff to a very exaggerated degree because we think this could potentially happen again. Then you get some neuroticism and some, the way of thinking changes a little bit, right? So that's epigenetics in terms of passing it on from one generation to the next. You have to then sit back and realize our genome is as it is in its current state. It has been like this for 200,000 years, right? So you're not inheriting grandma and great grandpa's legacy. There's people that were living in caves that you don't know about you are designed to be like.
Yeah.
Your genome, we became who we are 200,000 years ago. That's when our brain developed to the degree it is. The neocortex kind of developed. There's some random sort of changes that happened in our genome that gave us complex speech and complex thinking. We became who we are. There hasn't been any change since then. So if that's the case, modern agriculture started 10,000 years ago.
Right.
Out of the 200,000, right?
Yep.
Industrialization started like 300 years ago, maybe? Food being a threat started maybe 2 generations ago. The absurd chemical usage and the prolific, it's just everywhere, is maybe in the last 30 to 60 years type of thing. So if any species was doing one thing for 200,000 years, meaning that the way you had to deal with the environment and your food and your stress and all was like this, put it in this bucket, and all of a sudden it is completely flipped on its head, and you have 200,000 years of inherited genetic data that's designed to make you thrive and survive, and the context is completely changed. Everything you eat is a threat. Everything you breathe is a threat. Everything you clean your countertops with it is a threat. When you pick up your dry cleaning, it's a threat. Your mattress is a problem. It has fire retardants on it that you're breathing all night while you're sleeping, right? So we are not designed for any of this. And you wonder why we have a $4 trillion healthcare budget and 90% is spent on chronic disease that you're not born with, that all develops over time. So this is where it's really, really super important to understand that you may feel like this is normal because everybody's in it. It's not. everybody's in a mess that we're not supposed to be in. You have to take care of it.